All right, boys, good morning or good afternoon. Okay, today we're going to be talking about multiplying special case polynomials, okay? When we talk about special case polynomials, we're talking about polynomials that have a constant format, if you will, when you multiply them. Every time you multiply these type of polynomials, you're going to get the same kind of format. So what are we looking at here? First type that we're going to be dealing with is the square of a binomial. Now, the square of a binomial, think about the words. We're talking about a binomial, so we're talking about how many terms? Two terms, very good. And we're talking about the square, so what does that mean when we square something? Exactly, you're multiplying by itself or you're raising it to the second power. Excellent. So right here we've got x plus y squared. So that is the square of a binomial. Now, what happens here? What happens here is very simple, guys. You're going to always end up with x squared plus 2xy plus y squared. Now, why? What happens here? Well, what's happening here is whenever we multiply, okay, or square a binomial, you're going to first square the first term, okay? You're going to square the first term. What is the first term here in x plus y? X, so what's x squared? X squared, boom. Plus, because you have a plus here, plus, you're going to find the product of the first term and the second term, and you're going to multiply that by 2. So you're going to find twice the product of the first and the second term. That's how I get 2xy. Because what's x times y? No, what's x times y? Times 2. Bam. Do you see that? Okay, next it's going to be y squared. Why does that happen? Because we're going to square the last term. So the last term is, and what's y squared? Bam. Okay, does that make sense? Okay, now let's go ahead and do an example here. If I have x plus 4 squared, I have a square binomial here. What's happening? I take the first term and I square it. So what's the first term here, guys? So I have x squared. Second, what's the second thing we do here? Excellent, that was good. You multiply the first and the last, which in this case is 4 times x, which is 4x, times 2. Boom, 8x, done. And what's the last step? Square the last term. So the last term here is, so this would be 16. Very good. Varas, come here, my man. How about this? How would I do x plus, let's just make it easy, 3 squared? Talk to me, my man. What are we doing?
First make the first term squared, so it's x squared, and then you
Hold on. Okay, this is a lot. Okay, my man. How do we do this, brother?
first you would square the first term, which would be x, squared.
Correct. Good job.
Multiply the first and the second term, and then multiply it times 2, which would equal 6x.
Yes.
Then you multiply the last term by itself, so it would equal 9.
I couldn't have done it better myself. Awesome. Does that make sense, gentlemen? Yes? Okay. What if I increased it a little bit? What if I said to you 2x minus 1 squared? Who wants it? Who wants it? All right, Johnny. You have your hand up right now. Let's go, Johnny. See what you got. See what you got.
Okay, so first square the first term.
Correct?
4.
There you go. 4x. Yes. Good.
Then you twice the product of the 2 terms.
Correct, sir.
So 2x times negative 1 is negative 2x.
Don't put the negative. Remember, we have a plus here. So it's just the first 2 terms. So what's 2x times 1?
2x.
And then times 2?
4.
4.
4x.
Excellent. What's 1 squared? It's 1. No, just 1 squared is just 1, my man. You get rid of that squared. Excellent, buddy. Make sense? Awesome. Okay. That was awesome. That was like a high head five. Okay. Now, What if we have x minus y squared, okay? When we have x minus y squared, guys, the procedures are identical. Except, do you notice how I have a negative here now? All right, so big deal. Now it's going to be a negative. So I'm going to first have the square of the first term minus this time twice the product of the two terms plus the square of the last term. So it is identical, except we have a negative now. Does that make sense, gentlemen? Okay, awesome. So for example here, I gave an example as well, and I put x minus 3 squared. X minus 3 squared. My first term is going to be x squared because I take the first term, which is x, and I square it. Done. X times 3 is 3x, times 2 is 6x. Done. Why don't I have a negative there, though, guys? Because I have, not because I have a negative 3, but because there is a negative inside of this perfect square binomial. Does that make sense? Okay. And then the last term squared, 3 squared would be 9. Does that make sense, gentlemen? Awesome. May I continue? We're good? All right. So let's continue. Now, let's find each product. All right, let's see. Who else wants it? Adam, let's go. Try one, my man. See what you got. Adam, let's do it. You're fine, Adam. Correct, sir? I want to see all of you writing these. What's x times 8? There you go, times 2 is 16x. Good. That's the way I like to do it. Awesome. Guayo, let's go. Come on up, my man. See what you got, brother. Let's do B. Please. Write them all down, my man. You're not done. Thank you, sir. Good, good. Sir Quail's not talking to us. Okay, no, sir. Close, but no cigar. Think about it. Don't we have to take the first term and square it? So what's 2m squared? There you go. 4m squared. Good job. Now, second part. Isn't it 2m times 3? What's 2m times 3? 6m times 2? 12. And this is going to be a minus, right? Because there's a minus there. So minus 12m. And then the last term is 3 squared would be 9. Does that make sense? Good try, brother. That's the way we learn, by making mistakes. It's no big deal. All right, who else wants one? Let's go. Come on up, Pierce. Come on up, my man. Tell the crowd what we're doing, man, to help them out. Come on. Correct? Correct, son?
7 squared.
That's absolutely correct. 100%. Awesome. Way to go. All right, one more. You want it, Danny? Yeah? Come on up. Come on, come on, come on. You got this. Take your time. What do we do with the first term? Lefty. Perfect, perfect. Yeah, that's okay. Take your time. 2x times 9, which is going to be, and then times 2. 36, correct, my brother. Yes. And that's it. Awesome. Does that make sense, gentlemen? May we continue? All right. Now, what about a real world situation here, okay? Oh no, I know, word problems, we gotta learn. A square outdoor patio is surrounded by a brick walkway as shown. What is the area of the walkway? All right? What is the area of the walkway? Well, let's think about this, guys. We're talking about areas here, right? We have two distinct areas that we're dealing with here. We have the area of the actual patio, okay? And what are the dimensions of this patio? What's the width here? It's in red. X feet, right? And what's the height of this patio? X. Okay. So do we remember what the area of a square would be? Base times height, or side squared. So the patio area would equal, in this case, x times x, correct? Which would be x squared, feet. Does that make sense? And it's also feet squared. Right? Does that make sense so far, guys? You with me? Now, check this out. We have, in between the blue and the green here, gentlemen, that is the actual walkway, okay? That's where people will walk around. It's kind of like a sidewalk. They walk around and da-da-da-da. Okay, that has an area as well, okay? What is the entire area from edge of the walkway to the other edge of the walkway, including the patio? What is the whole entire length there? X plus 6, that's exactly right. What is the height from walkway to walkway? Okay, is that still a square? Okay, what is the formula for the area of a square? Side squared, very good. So the area, the total area of this figure is going to be x plus 6 squared. Very good. Now, here's the beauty. If we know our format for the perfect square binomials, we know this is going to be x squared plus 6 times x times 2 is 12x plus 6 squared is 36. 12x, yes, thank you very much, guys. Does that make sense so far? Now, here's the trick. How do we find the area of just the sidewalk? That's it. Awesome. Guys, do you see what he just said there? If you take away the area of the patio, what are you left with? The walkways area. Very good. So what am I going to do? I'm going to go x squared plus 12x plus 36 minus x squared. We know how to do this already because we learned that yesterday, right? We combine like terms. The x squareds cancel. And my area is going to be 12x plus 36 feet squared. Does that make sense, gentlemen? You sure? Promise? All right, awesome. Thank you. Thank you very much. All right, boys. Now, let's finish this up. This is a product of a sum and difference. Okay? This is the second type. The product of a sum and difference. Now, this is very, very, very easy. When you have a plus b times a minus b, your product, I promise you, will always be a squared minus b squared. And I'm going to show you why, guys. If we FOIL this, what's a times a? What's a times negative b? What's b times a? And what's b times negative b? Am I not left with a squared minus b squared? Yes. Does that make sense? So this one is the one, remember how I said yesterday, I should have said it today, the first two that we learned, it's awesome to memorize because it makes your life so much easier, so much quicker. But you don't have to, okay? This one, it is awesome to memorize it, but you don't have to. You could go the long way, Okay? Now, Mr. Morrow, if you can go the long way, what's the point of doing this? For speed and accuracy. Yes, sir. I'm going to show you right now, my brother. So what he wanted is an example. So for example, what if I tell you this, dude? 4x plus 3y times 4x minus 3y. Whenever your terms are exactly the same, but the only difference is one is being added and one is being subtracted, my brothers, first term squared, 16x, minus the second term squared, 9y squared. Okay? And actually, I jumped the gun here. I made this a little bit prettier, and I forgot to. Sorry. A squared is the square of the first term. Minus this time, okay? Because when you have a plus or minus, it's always going to be minus here. And then, boom, the square of the second term. All right? Does that make sense? So, we don't have to memorize these. But I will tell you what. When we're factoring, which is coming up tomorrow, okay? Tomorrow. All of these things are going to help you out. So, on a test or on an SAT, if they tell you simplify x plus 7 squared, I'm going to always do it the quick way because I'm used to it. I'm going to go x squared plus 14x plus 49. Whoop-de-doo for me. I've been doing this a long time. You guys don't get the rhythm yet? Are you allowed to break it up like this? X plus 7 times x plus 7? Heck yeah. And then just FOIL it. X squared plus 7x plus 7x plus 49. I swear to you, as long as you add correctly, you will get the same answer. Now, is it as quick as the other way? No. But you're still going to get it right. So what I'm saying is, if you're on a test or a quiz and you get jammed up and you're like, oh my God, I forgot. So what? Just do it the long way. When you're factoring, it's not that easy, but this way it is. Same thing for the difference of squares, okay? If I give you 2x minus 3 times 2x plus 3, the easy way, square the first term minus the square of the second. But if not, you could FOIL and cancel it out to this. Thank you very much, guys. God bless you. Have a great